So what we have seen in the previous two videos in multithreading in Java, we have seen the introduction to multithreading. What is multitasking? There are two types of multitasking, process-based and thread-based. Important question. Then the difference between process-based and thread-based multitasking, correct? Then we have seen the objectives and the areas of multithreading, correct? Then we have seen what are threads. Thread is nothing but an path of execution, a flow of execution. Okay, now defining a thread means we are two ways of defining a thread, that is extending by thread class or implementing runnable interface. So we will see different methods in the thread class. And what is runnable interface? It contains just a single method, and whoever is implementing that interface, it has to implement that run method, correct? Then we have seen how we will define a thread by extending thread class. So how you will do it? It's very simple. We will have a child thread that extends a thread. Our class will extend the thread class. Then we will override the run method inside of it. Okay, the run method is present in the thread class, but it has an empty implementation. It has an empty implementation. Okay, so what we will do? We will simply override that method. We will simply override that method. So we have done this. So this is known as the job of my child thread. Okay, now class test, main method, the object of child thread, we will call the start method, and this is the job of the main thread. So what we have seen in this part is each Java program by default has one thread, that is a main thread. Before ct.start we have just one thread. After ct.start we have two threads. Okay, now both threads will run simultaneously and job will be executed, but the order of execution is dependent on thread scheduler. It is not dependent on us. It is dependent on the algorithm that is that thread scheduler uses. Fine. So since the jobs are independent, all that matters is that they get completed as fast as possible. Order of execution does not matter. So now in this video we will see what a start method and run method. More deeply we will see start method and run method. Okay, so let's now begin with our start method of thread class. This is the same example that we have seen previously. Fine. So as you can see here in this line, I am calling a start method with a reference variable ct. Ct is a reference variable of child thread class, but inside our child thread class there is no start method. There is just one method known as a run method. So how we can call start method when there is no start method in the child thread class? Can you guess? Can you guess the answer? You know the answer. It is based on inheritance. I think most of you did. So how you will do it? Since it extends the thread class, so all the thread class methods are also accessible now. So start method is actually present inside our thread class. So important point, start method is present inside our thread class. Okay, and inside the start method we have a call to run method. So by default it will call the run method of thread class, but we have overridden that method. So this run method will be called and the job will be executed, Okay, so ct does not contain, that is our child thread does not contain the start method. So we will check in the thread class. So thread class does contain the start method. Okay, and this start method in turn call the run method. Okay, this is how it happens. Fine. So now the question is, why do we have to call the start method? Why can't I call directly the run method? Why can't I write ct.run? Just think about this question. So what is the question? Why don't we directly use run method in test class? Why don't we do it? Why don't we directly write ct.run? Can you think about it? I have said one line in the last class which is the answer. So why don't we use directly run method, that is ct.run? Why don't we directly do it? Can you guess? Why don't we directly do it? Just guess. Okay, so let me give you the answer for this one. The answer is very simple. New child thread will not be created if we directly use run. New child thread will not be created if we directly use run. It will behave as any other function call. So what is the meaning of this line? The meaning is actually very simple. The main thread is executing, correct? Whenever start method is called, a new thread is created and the main thread will execute, and a new thread, a child thread, will be created. Am I correct? So whenever start method is called, then a child thread is created. This is an important line. Whenever start method is called, then a child thread is created. If I directly call the run method, new child thread will not be created. Okay, it is a functionality of a start method to actually create a new thread and then call the run method. But if I directly call the run method, new child thread will not be created. Am I clear? New child thread will not be created. So what will happen? The main thread will be running. The main thread will be running, and it will behave. Run method will behave as any other method. As any other method. Let's see. So here, when if I call directly ct.run, so what will happen? The main thread will only execute this. It will go here, and the main thread will execute the whole process, and the main thread will finally do this. So our answer will be simple: child thread 5 times and then main thread. Okay, a single thread main is running. This is a simple Java program. This is a simple Java program now. If I remove this line, this is a simple Java program now. Okay, the run method will be called and it will be executed and done. No new thread will be created. Okay, so to create a new thread, we have to call the start method. To create a new thread, we have to call the start method. Okay, so start method performs various operations in the backend. It is not just calling of run method. It performs various operations. What are those operations? Register the thread with thread scheduler. Okay, we need to register the thread with a thread scheduler. This is taken care by our start method. Okay, then perform all other mandatory activities. There are other activities as well, and finally invoke run. Okay, so these two activities actually create a new child thread. Okay, and after creating the child thread, it will invoke run, and our run method is overridden in our child thread class, so that run method will be executed. This is the importance of start method. So what are the question? So what is the difference between start method and run method? Why don't we directly use run method? Or the interviewer can also ask, what is the importance of start method? Okay, where the start method is situated. So the start method is implemented in the thread class. Okay, these are the important points of the start method. Okay, why don't we directly use run? Because a new child thread will not be created if you directly use run. Okay, so this is the importance of start method. Am I clear? I think it is very clear. Okay, so let's now move to our next topic, that is overloading of run method. Overloading of run method, not overriding, but overloading. Okay, now let's see a code. So first point is, the question can be asked, is it even possible to overload run method? Is it possible? Will it give an error? So the answer is no, it will not give an error. So this is my child thread class that extends the thread class. Okay, this is a public void run. So this is overriding of my run method. Correct? The thread class contains a run method, but it also has what? No lines of code. It is an empty implementation. So it is overrides. This is a single job that this run method has to perform. Now we are overloading. What do you mean by overloading? The name is same, but the parameters are different. It is no parameter, it is a single parameter. Okay, and this is overloaded method. This is the job of this one, and we will create a class thread. This same things will happen. ct.start. Okay, so this is our main thread. After ct.start, we have two threads. There is a child thread and our main thread. Okay, now it will be executed simultaneously. Now tell me what will happen. Which run method will be called by the start? This one or this one? Which run method will be called by start? Okay, now tell me. Now let's just think. So start method is not present, so it will go to the thread class. Thread class contains the start method. It will perform these 3 steps which I told you: mandatory activities, the thread scheduler 1 step, and the last step, that is invoke run. So which run method will it invoke? So just keep this point. The start method in thread class always by default calls the no parameter run method. Which one? No parameter run method. Always no parameter run method. Am I clear? It will always call no parameter run method. Okay, so what it will print? It will print child thread. Okay, if you want to run this one, actually what you have to do, you have to just simply from your main class, you have to call ct.run 5. Okay, it has nothing to do with the threads. This is just a simple normal method in our Java program. Okay, so it will just behave as a normal method as well. Fine. So what is the point? We can overload the run method, but if you overload the run method, that overloaded method will just simply behave as a normal method. Start will always call the method with no parameters. Am I clear? So this can also be asked in the interview. Fine. So just keep this in mind. What are the important points here? The important point is start will always call the method with no parameter run. Okay, though we can overload. Do not say we cannot overload. Okay, it will not give an error, not compile time, no run time. We can overload, but the point is it will behave as a normal method. Fine. So this is the code that I have seen. This is overload run demo. Okay, So public class overload run demo, here we will contain our main method. So the main thread will begin. Before r.start there will be just a single thread, and after r.start there will be two threads. Okay, in our child class, that is overload run child, it will extend the thread. It will have two methods, that is run method with no parameter and overloaded run method with a single parameter. Okay, whenever we call r.start, it will always call the run method and it will print normal run. It will print normal run. Okay, it will not show any error and nothing. It will simply print normal run, as you can see. Fine. So if you want to print overloaded run, you need to just write r dot run and you need to pass an integer into it. Okay, just as a normal function call, just a normal method call, and just run it. So now it will first print normal run and then it will print overloaded run. Okay, now it is not that case. It is not the case. Okay, why it is not the case? Because this r dot run will be executed by main thread, and this normal run will be executed by child thread. Now the execution order is not same. It is not, we cannot predict the execution order. Okay, it will be different. So in this case, the first one priority is given to the main thread, then the priority is given to the child thread. Okay, now it can be the case every time. It can be the case every time because the main thread is running. So since it is in milliseconds, so the main thread will be given the first chance because the main thread is running from previously, correct? So but we have seen in this one here that main thread can be the second one, then the child thread will be given a priority, as we have seen in this one before also. Here the main thread again is given the first priority, then here you have a child thread. So the order of execution is just not in our hands. It simply is, it is not in our hands. It is totally dependent on, see here, this time child thread is given the priority, so it is totally dependent on the thread scheduler. Okay, but what I am saying is this will be executed by main thread and this will be executed by child thread. Okay, so here it goes, that is we can overload the run method, but the point is start will always call the run method with no parameters. Okay, now let's see another point. So this was overloading of run method. Now let's see overloading. So what are the important points? Is it possible to overload run method? Yes, it is possible to overload run method. The catch is start method in the thread class will always call run method with no parameters. You can just make these notes. The overloaded run method will behave as any other method in Java. Okay, so let's see now overriding of run method. Now we have been overriding run method. Okay, so why this point? Why this statement overriding of run method? The point is what will happen if we do not override the run method. Okay, I have told you the answer before only. Just think, what if we are not overriding the run method? What will happen if we do not override the run method? For example, this is the case. We are not overriding the run method. We are not implementing our own run method. So what will happen? What will be the output? Most of you I think can guess what will be the output. I have said these lines many times. So let's guess what will be the output. So the child thread, new child thread. So child thread will call the start method. There is no start method. It will go to the thread class. Start method will be present. Now start method will do the first and second steps and then it will invoke the run method. Now the run method is not overriding here. It is not overridden here. So it will call the run method of where? It will call the run method of thread class itself. Now the run method of thread class, I have told you this previously, is an empty implementation. It is an empty implementation. There is no lines of code here. So the output will be nothing. The output will be nothing because the run method will execute. There are no lines of code to execute. So it will not print anything. It will not print anything. So this is the case if we are not overriding run method. Okay, so this is why it is important to override the run method. If you want something as output, you have to override the run method. Okay, so will it give any error? The first point, no, it will not give any error. It will not give any error. Okay, will it print anything? No, it will not print anything. Fine, because the implementation inside the thread class is empty implementation. You have to actually write the job here, whatever you want the child thread to do. Fine, so this was overriding of run method. What will happen if you do not override the run method? No error will come, but no output will also come. Okay, you need to override the run method. Fine, so thread class run method will be called and it has an empty implementation, so no output will be printed. It is as simple as that. So let's see the code. So I think you know what will be the output. It is the same code, so the output will be nothing. See, nothing is printed because we have not overridden our run method. Okay, so after this, let's see overriding of start method. What if we override the start method itself? What will happen then? Let's see the code. So child thread extends thread, public void start, okay, and overriding start, public void run, normal run. and this is happening. So now what is happening? Now ct.start, whenever ct.start will be called, since my start method is present in my child thread class itself, so it will not go and perform and execute the start method of thread class, because we have overridden the start method, correct? So start method, this will be executed, and the output printed is simply overriding start. It is simply overriding start, correct? So what will be the difference? What will be the difference? The first point is no new thread will be created. No new thread will be created, correct? The second point is run method will not be invoked. Run method will not be invoked because our start method job, which we have overridden, is just to print overriding start. It will not schedule the new thread on thread scheduler. It will not perform any other mandatory activities, and it will not invoke the run method. It will not do any of these things because the job is just to print overriding start. Okay, so if you are overriding the start method, these things will not happen, and these things are very important. So currently just a single thread is executing. This is the main thread. No new thread is created. No new thread is created. Okay, so it is not recommended to override your start method. Okay, start method have such a big line of code, the implementation inside our thread class. Okay, you do not need to write that. Only the run method you need to override. So what we have seen in this video, can you summarize it now? Because we have seen many things, correct? So what we have seen overriding of start method, we have seen overloading of run method, we have seen why should we override the run method, we have seen why should not we override the start method, correct? So do not get confused, just see the video again. It is a very simple concept. There's a small concepts merged into a single video. Okay, what is the difference between start and run? What is the importance of start? Correct, we have seen all those points now. Fine. So now start method of thread class will not be executed, so new thread won't be created. Start method of child class will be executed as a normal method, and then will not be executed. Okay, so the output will be printed by main thread as no new thread is created. Fine. So these are the important points that we have in overriding of start method. Okay, and then it is not recommended to override start method. This I have already said. It is not recommended to override start method. Fine. So this is the points and this is the video. So these are all the important points. You can just make a note of them. Okay, so these are all the cases that we can have in our thread, in our class, in our programming that you do. Okay, so you have to take these points into consideration whenever you program any multi-threaded program. Okay, so there are some important interview questions here, so just make a note of them also. I have just written those questions. I have said those questions many times inside this video. Okay, so in the next video now we will see what are thread lifecycle, what is thread scheduler, and what is the lifecycle of thread. Okay, thank you.